Hey there, everyone. Today I want to talk about the topic of model drift. Okay, so this is what you see sometimes when, as time goes on, the model will um, become not quite as well trained as it initially was, right? So we're going to have to do a simple calculation to see how well a model was trained, how accurately it performs, and then is it drifting or changing over time, right? This is something that doesn't happen in a day, but it can happen over a period of weeks or months. Certainly, it's possible for the model to drift. If it drifts too far, it might not be learning as accurately as it originally did. Sorry, so that's what we're gonna focus on today. So model drift essentially is very useful for performing overall accuracy and relevance for machine learning models, right? It helps us to maintain predictive capabilities of the model and ensures business relevance, right? Helps to improve the customer experience. It satisfies regulatory compliance mandates, right? We could work in a very highly regulated environment, and regulation can be a huge part of the business, right? So we have to be aware of that. Helps us to identify the needs for updated data collection processes that optimizes resource allocation, and also helps to enable proactive model improvement, right? We want to get ahead of this thing and understand, is the model performing accurately, or is it not, right? As time goes on, the model can drift slightly and thus not learn as accurately. So we'll have to retrain the model, right? But only if there's drift. If there's no drift, then there's no point in doing the retraining. So I'm going to import data from this canonical, very classical type of data set, MTCars. I introduced this in several of my other videos I've posted here. Okay, we're going to look at the independent and the dependent variables. Control Enter to refresh. So the dependent is the Y, right? That's what we're trying to predict. And the X variable is the independent. So I'm dropping the MPG column from this data frame, right? That's the first column. And I'm keeping all the other columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 independent variables and one independent, right? So, one dependent. There's always one dependent, and the number of independent can be anywhere from a couple or handful up to hundreds or even thousands potentially, right? So we went ahead and trained and tested the model. We're going to use an XGB regressor here because these are all numeric data types, right? So I ran this. We're getting an accuracy of 0.70. So that is like the bare minimum threshold to be considered statistically significant. Anything higher than 0.7 is better, right? We want to say it's close to 1.0, but we probably won't get perfect R squared, right? We'll probably have some break in the data due to scattering of data points, unless the data is perfectly aligned with the least fit curve. That could be, but that's highly unlikely, right? So we have 0.70, and there's ways to improve that. I have other videos on how to get the R squared higher and higher. But we're not going to focus on that today. Today we're looking at model drift, right? So we have our X and Y variables. We're going to set that in the regressor. Actually, I already did that. We didn't have to do it twice, right? Where's the fit? The fit is right here. So let me I'll comment this out. I'll leave it in there, but I'll comment that. I'm going to share all this code with you guys when I post the video, right? So you'll have everything, copy and paste it, and run it in your own environment and see how this works. Basically, I didn't even need the step, but if you wanted to see all of the parameters here that you could tune to get this regression model to perform better, we can get this 0.70 higher. We have other videos on how to do that. I'm not going to focus on that here, but here's a viewpoint or perspective of all the parameters that you can tune to try to improve the training and the testing of this model, right? Okay, so now we're down to the point where we can go ahead and get some basic metrics. I want to look at the MSE. This is the mean square error, RMSE, mean square error, and the R squared. Okay, so we can see this printed out down here. So these numbers are okay. 12. This is lower is better here, lower is better here, higher is better here. Okay, we're looking at a couple different things. And that's okay. We don't have a perfect model. Sorry, let me delete that. That was from something else before. We don't have a perfect model. 29% of the time, it's making mistakes, but we can live with it. Okay, this is okay for our purposes here. What we really want to do is understand: has any drift been detected, and if so, we need to retrain the model. So that's what this is doing for us, right? So there was some drift detected between the first time running the model and the second time. The model was retrained, and we went from 0.70 to 0.71, so we had a slight improvement in the performance. As you recall back here, we had 0.70, Now we get that up to 0.71, so it's 71% accurate, right? So that's so this exercise helped us understand the model drift, right? And it did result in a slight improvement. Now, rather than just tracking MSE, RMSE, and R squared, and there's a few other metrics we can look at too. There's a few libraries out there or a few methodologies that we can use to also test for model drift. There's a KS test. I'm not even going to try to pronounce this thing, okay? I'll leave that to you guys to do that. But it's sometimes go by the name of KS test. And there's a drift detection package. So let's look at this, both of these right now. So here's the KS test. I'm going to go ahead and apply that. We're going to see if any of the individual features have experienced any kind of drift. And in this case, no. There was p-value 0.82, 0.08, 0.13. We want lower p-values. 0.05 is considered statistically significant. So all these are a little bit high, and that's okay. But we're not looking at specifically at p-values for this in this video. I've got a couple other videos that I get into that. But in this case, there was no drift detected, right? So we used the KS test. It's a little bit tricky to say. KS test to determine if there was any drift in the model, and there was not. Okay, so I think we're fine with that. So the likelihood of observing any kind of distribution for each feature could trigger a drift change, right? And we'd have to retrain the model. In this case, we're fine as is. We don't have to do this. The data set is pretty simple and pretty straightforward. I wanted to do something that's pretty much generic to try to help you to understand the concept of model drift. And I hope that it's generic enough that you can just take and copy this code, make a couple small changes to your specific data set. All you'd have to do is feed the data into the data frame, right? You'll get your X train, the new, X new over here from these small scripts above. So this is pretty simple video, pretty short too. I think that's pretty much it. That's all I really wanted to cover here. So that's it. I want to make the video to introduce this topic. I think it's interesting. I think it's very relevant. And I try to keep it generic so you can copy and paste it. Essentially, put your data frame right here. Right? Load your data frame into the df variable and do the same analysis, and you should get results that work in your specific data set, right? I tried to make these generic enough so you can copy and paste the code and make a couple small modifications. And with those updates, right, run it on your data, right? That's what the point of these videos is, to help you learn these topics and make it work on your specific data set, right? I wouldn't expect too many people need to do a model drift analysis on the MTCars data set. But on your specific data set, it's absolutely going to be necessary. Okay, so I hope that explains the concept. And I think we covered pretty much everything here. Okay, that's it, guys. I'm going to wrap it up now. Thanks for your time today. Have a wonderful rest of your day. Thanks. Bye.